Hi, this is Ms. Kidman, and we are going to be talking about solving absolute value equations. So just as a quick review, what is absolute value? Well, absolute value is the distance away from zero. That's all that it is. So when we talk about that absolute value, usually we see it in a math problem, and we often see it represented by two vertical lines. There's a number sometimes inside, there's an expression, whatever it is. But it's talking about that distance away from zero. So if we had the absolute value of a number like 3 inside, what that means is that the number 3 here is just 3 steps away from zero. Okay? Same thing happens if you have a negative number like -4. All we have to do is count those steps away from zero, and we can see what that equals. So the absolute value of -4, we can see, is 4 because it took 4 steps to get to zero. So that is really what absolute value is. Now we're going to use absolute value in equations, and we're going to be solving those equations. So for example, this equation says the absolute value of x equals 10. Now, what that's really telling us is it's asking us what number is 10 away from zero, or this idea right here, what number is 10 away from zero? Well, based on our number line, there are actually two numbers that are 10 away from zero, both 10 and -10. Both of those numbers, if we count out 10 steps away from zero, would be 10. So there are two solutions here, x equals 10, as well as x equals -10. Now, anytime that an expression within an absolute value equals a positive number, we're going to have two solutions, because the distance that a number is away from zero can either be that distance in the positive direction on the number line or in the negative direction on the number line. Because it can be both, we're going to have two solutions to those. So the absolute value of x, when does that equal 7? Well, what numbers are 7 away from 0? That's going to be when x is 7 and when x is -7. Now this next example here, the absolute value of x equals -3, that's a unique example. Now notice how this equals a negative number. Now, we talk about the definition of absolute value as being the distance away from zero. Distance has to be positive. Think of it like if you were walking. If you walked from your house to the school, you're walking a distance. If you go from the school back to your house, you're not losing distance because you're walking in that backwards direction. You're still walking that same distance, just facing a different way. So similarly, absolute value is always positive because distance is always positive. So is it possible for a number to be a distance of -3 away? No, that's not possible. This is not possible. In math, when something is not possible or it's impossible, we say that there are no solutions, because there is no numbers that I can put in for x there to make that statement true. Feel free to try it, but it's just not possible. These other two examples work just as well. If the absolute value of x equals 7/3, well, what two numbers are 7/3 away from 0? 7/3 and -7/3. So it works out the same way. Lastly, the absolute value of x equals 0. Now, putting it back into that idea, what number is 0 away from 0? Well, 0 away means it's the same number. So the only number that is 0 away from 0 is 0. So the absolute value of x, when it equals 0, x has to be 0. And that's kind of that absolute value. Now, let's look at it in a more complex way. Instead of it just being the variable x, we're now looking at this expression, x plus 5. If I were to write this idea of x plus 5, the absolute value of x plus 5 equals 10 in a sentence using words, I would write x plus 5 is 10 away from 0. That's what it means there. So x plus 5, now that's mathy, so we're going to leave that there. But I'm going to change this sentence here into an equation, because an equation is just a mathematical sentence. So x plus 5 is, and math is means equal to, 10 away from 0. Now, we just learned on that last slide that there are two numbers that are 10 away from 0. It can either equal 10 or x plus 5 could equal -10. We have both of those options. And every time we have an absolute value, as said before, on one side, whatever that's equal to on the other side, it will be equal to both the positive and negative version of that. So this absolute value of x plus 5 equals 10 breaks down into two equations. And notice that there are no absolute value signs around that x plus 5 anymore because we got rid of it. Absolute value makes our equation more complicated, and we don't want that. So here we are. To solve these equations, we just have to solve for x. So to solve for x, I'm going to subtract 5 from both sides on this one. These will cancel out, and I get x equals 5. Pretty straightforward. We can do the same thing on this other side, subtract 5, and I end up with x equals negative 15. Now, does this give us both the right answers? That's a tough question, but one thing I can easily do is check my answers. And the way that I would check those is I would just plug my solution back into the original problem and see if it works out. So in this case, the absolute value of, instead of x, I'm going to put 5 in, plus 5. Is that equal to 10? Now we can figure that out. 5 plus 5 is 10, so the absolute value of 10, is that equal to 10? Well, the absolute value of 10 is 10, and 10 equals 10. So this answer here is definitely a solution. And we can check the other one the same way. So I'm going to substitute in that negative 15 for my x and do negative 15 plus 5. Does that equal 10? Now, what is negative 15 plus 5? That equals negative 10. So the absolute value of negative 10, does it equal 10? Well, the absolute value of negative 10 is 10 because it's 10 away from 0, and 10 equals 10. So these two are the solutions. Now we can check right here with this method every single time to see if that works. It's a great resource. If you aren't sure if you got the right answer, you can just plug it back in and see if your expression works out. And if it does, you have the right answer there. Let's look at this next one here. So we've got the absolute value of 2x minus 3 equals 7. Now remember, this number on that it's equal to, that integer, we want the positive and negative version of it. So we're looking here, and we're going to create two equations. We've got the equation 2x minus 3 equals 7, and the other equation 2x minus 3 equals negative 7. And notice, by doing it equal to 7 and negative 7, we can get rid of that absolute value. Now we're going to go through and solve these equations. So I'll add 3 to both sides, and we get 2x equals 10, divide by 2, and I get x equals 5. Similarly, we can do the other one, add 3, we get 2x equals negative 4, divide by 2, and we get x equals negative 2. So these two are solutions. X equals 5 and x equals negative 2 are the two values for x that work for this equation. And that, in a nutshell, is finding the answers to absolute value equations. There are a couple of exceptions that we can look at. Again, in this case, we have the absolute value of 2x plus 1 equals negative 7. Now we know distance can't be negative, so having this negative 7 as an answer isn't possible. Therefore, this one has no solution. The other one we have here is the absolute value of 5x minus 10 equals 0. Now, if that's the case, remember, 0 isn't positive or negative. 0 is 0, and the distance from 0 to 0 is 0. So there is only one solution here. So we're looking at 5x minus 10 equals 0, and we can just solve for x that way. Add 10 to both sides, 5x equals 10, divide by 2, x equals 5, and that's our solution there. So as a quick recap here for you, if our absolute value equals a positive number, then we have two solutions. If it equals 0, then we have one solution. And if it equals a negative number, then we have 0 solutions. And there you go. That's solving absolute value equations.